Welcome, guys. Welcome to Tutor Sam Academy. Today, I'll be taking Alkane, and under Alkane, we'll be talking about what Alkanes are all about. We'll talk about their nomenclature, that is how to name them. We'll talk about their isomerism. Then we'll also look at how to prepare Alkane, the laboratory preparations of Alkanes, and their properties, that is their physical and chemical properties. Also, finally, we'll look at the uses of Alkane. So what are alkanes all about? Alkanes, what are they all about? Alkanes are non-functional group compounds. That is, it doesn't have a functional group. It doesn't contain anything like functional group. They are made up of carbon and hydrogen. Alkanes belongs to hydrocarbons. So they are non-functional group compound. First thing you should take note of alkane is that they are non-functional. They are non-functional. They contain carbon and hydrogen. Carbon and hydrogen atom. Alkane are non-functional group compound. They are hydrocarbons. That is, they contain carbon and hydrogen atom with a single covalent bond. And alkane has a single bond. So, single covalent bond between the carbon and the hydrogen. Alkane are non-functional group compound. They don't have a functional group. They contain carbon and hydrogen, that is, they are hydrocarbons, and also they contain a single bond between the carbon to carbon bond. Alkanes are also also aliphatic compound. The aliphatic compounds with saturated, that are saturated. The aliphatic and saturated carbon hydrocarbons. They are aliphatic. They are aliphatic and saturated hydrocarbons. Saturated hydrocarbons. So this is a very brief introduction on alkane. So you should know that alkane, whenever you're talking about alkane, they don't have a functional group. They have carbon and hydrogen atom, that is, their hydrocarbons. They have single bond. When I mean single bond, I mean that between each carbon to carbon, there is only a single bond between. There are some unsaturated hydrocarbons that have double bond, but in alkane, they have a single bond. They are aliphatic, and finally, also they are saturated. They are saturated means that the alkane, they have a bond. A carbon can only have 4 bonds. That is, you can have a bond like this. A carbon can only have a 4 bond. Let's say a carbon bonded with hydrogen can only have a 4 hydrogen atom. So when the carbon atom is saturated, there will be 4 bonds attached to that carbon. So alkanes are a good example of a saturated hydrocarbons. And also alkane have a general formula. They have a general formula that you can use and know them. They have a general formula of CnH2n plus 2. So this is a general formula for alkane family. Alkane is like a family group. So each family have this identity. This is what will give birth to each family. General formula is like a means of achieving each of the member of that family. So this is what you will use to give birth to each member of the family. And the n here is the number of carbon atom. If the carbon atom is 1, that means n will be 1. If the number of carbon atom is 2, n will be 2. So let's look at an instance. Let's look at several instances where n can be. This n here can be 1, 2, 3, 4, 5, and so on. Let's say we have number of carbon. This is number of carbon. We have the name of the compound. We also have the molecular formula, and we finally have the structure. So let me have this column. If this is what we have, so number of carbon. Let's say an alkane have number of carbon 1. The name of that alkane is known as methane. Methane is known for a single carbon compound. And the molecular formula, since the carbon is 1, you will substitute 1 into that general formula I started with. The general formula is CN H2N plus 2. So when I have C1, H2 times N here will also be 1 plus 2. So this is C1 is C1, 2 times 1 is 2 plus 2, that is CH4. So alkane has a molecular formula of CH4. So structurally, I will have this as the structure of alkane. This will be a structure of alkane. So when we have a 2-carbon compound, let's say we have carbon is 2, the name of that compound is no longer methane. The name of the member of that family is ethane. And ethane, from that general formula CnH2n plus 2, will have C instead of N. Now the number of carbon now will be 2. H2 times 2 plus 2. So this is C2. 2 times 2 is 4. 4 plus 2 is 6. So it's C2H6. So this is C2H6. So structurally, here I will have 2 carbon. Then each carbon will be saturated with hydrogen. So this is the structure of ethane. This is a very good structure of ethane. So the third member, when carbon is 3, we'll have C3. So here we have methane, ethane. Here will be propane. And propane will be C3. When you substitute into that general formula, it will be C3H8. This will be C3H8. So structurally, it will be carbon. I will have my hydrogen bounded to each carbon. So this is the structure of propane. So you can draw structure for butane, which is the fourth member. We have butane. You can find the molecular formula butane. From butane, we have pentane. From pentane, this is 4, this is 5, this is hexane. We have heptane, which is 7. We have octane, which is 8. We have decane. Nonane before decane. So we have nonane. And finally decane also. So these are all the member of the alkane series. So do yourself well by trying to practice the structure and the molecular formula. So that is all about the family of alkane. So we can also look at the IUPAC nomenclature, that is how to name the alkanes. So all right, let's talk about the nomenclature of alkane. That is, how do we name the alkane? What are the things that you need to follow when you are naming any alkane? So listen carefully. I'm going to give you 6 things to take note so you can properly name any member of the alkane family or any structure that belongs to the alkane group. The first thing is to identify the longest continuous chain. You identify the longest continuous chain of the series. So if I have a carbon, first thing, let me say I have this. This is the longest chain, continuous chain from here. When you number from here, 2, 3, 4. So if I have this kind of structure, this is the continuous chain here is 4 with 4 carbon. So that one, the longest continuous chain, if it has 5 carbon, if it has 4 carbon, it will serve as your parent name. So if it is 4 carbon, this will be butane. That will be your parent name. It will be like, parent name is more like a surname. It will come at the end of the naming. So number 2 things you have to identify is to identify the substituent and the position in the carbon chain. The second thing is to what? Identify the substituent. First thing I said, identify the longest continuous chain. Then number 2, you identify the substituent. Let's say this butane has a substituent here. Let's say it has a substituent. Substituent is like a branch. If it has a substituent here, you identify that substituent and the position in the carbon atom, in the carbon chain, So if you look at this substituent, this is the longest chain which you have been identified. It serves as our parent name. This substituent is here. when you identify this substituent is a single carbon substituent, which is a methyl. If it is two carbon that is attached here, that is an ethyl. That ethyl serves as a substituent, but since I have a single substituent carbon, that is my methyl. So you identify that methyl, you identify the carbon on which it falls. If you look at this numbering, this is 1, 2, 3, 4. That means the methyl the substituent comes on carbon 2. So you call this compound 2-methyl. You add your surname, which I call the parent name, is what? 2-methyl butane. So this is the second thing you should take note in naming alkane. And also, the position number are placed before the name of the substituent in alphabetical order. If you look at, if this is the position number first, the substituent, then the parent name. But in case there are more than two substituents, you will put the position number. Let's say we have a substituent here. I have a substituent here, and I have another substituent here, and I have another substituent here. Let's say this one I have a 2-carbon substituent. So this is 2 different substituents. These are 2 different substituents. When you are considering this kind of substituent, you see this one is a methyl, this is an ethyl group. So both of them on carbon 2, you have considered your longest chain, which is butane. So you start with that butane, which is your surname, methyl on carbon 2, ethyl on carbon 2. So alphabetical order, you start with ethyl before methyl. So that will be 2, comma 2, 2 ethyl, or 2-ethyl 2-methyl butane. Let's name it like that. That will be 2-ethyl 2-methyl butane. So this is the name of this compound. So you can see that my number first, the position number of the carbon, the substituent, the position number, the substituent, and the parent name in alphabetical order. So the next thing you can also take note in naming it, if substituents occur more than one place on the parent carbon chain, have their position number separation by comma. So if they appear more than one chain, you have the parent, the substituent. If it occur more than once on the parent carbon, that is, you separate them by this comma. By this comma, you can see I separate my own carbon number from the substituent by comma, then this one by a hyphen. So that is how you name alkane. And we can also use prefix like di, tri, tetra are added in front of each substituent if there are more than one. For instance, if I have more than 2 ethyl, that will be 2,2-di-ethyl. If it is 3, it will be 2,2,3-di-tri-ethyl. So that is how you name. Then finally, if there is any electronegative substituents are involved, like chlorine, bromine, those one, you don't just put them we put them like with ending with something like this, bromo and chloro. You don't just write bromine, chlorine. So if it falls on any carbon, you take note of that carbon, then you complete it with bromo and chloro. So that is all about the IUPAC nomenclature of the alkane series. And also we can have structure like this. I've talked about the nomenclature, how you name them. So what if we have structures like this? How do we name them? How do you name such structure? So this is a very good example. First thing is to still take note of the longest carbon chain. We have 1, 2, 3, 4. This is 1, 2, 3, 4. So you can number like this. That means the parent name for this compound is butane. That will be the parent name because that is the longest chain. So if we have butane and we have, if you look at this butane, we have, you can number this way and still number this way. 1, 2, 3, 4. See the same thing. So you now consider your attachment. If you look at this, you have attachment, one attachment on carbon 2, you have another one on carbon 3. So this will be 2, 3 dimethyl butane. So this is the name of this compound because I have a methyl on the second carbon. I have another methyl on the third carbon. But if you are considering your carbon from this side, it's still on the side, it's on the second carbon. This is on the third carbon. So this is 2,3-dimethyl butane. Now let's come to this place. Here we have, if you name this, number this carbon 1, 2, 3, 4, 5, 6. So this is a 6 carbon. So this is hexane. Hexane. This is hexane. This is hexane. Let me put the parent name here. This is hexane. So we have substituent on this hexane. If you look at, I number from here, my substituent position on carbon 4. But when you number from this side, 1, 2, 3, 4, 5, 6, your substituent position on carbon 3. So we use the one with the lowest substituent. Instead of carbon 4, I use the one with carbon 3 because it's prioritizing the substituent more. So we have carbon 3 methane. So this is CH3. This is CH3. So this will be 3,3 dimethyl hexane. That's the name of that compound. So this is another compound. This one is having an electronegative compound, which is bromine. So naming this compound, we have 1, 2, 3. So since I have 3 carbon, that means my parent name here will be propane. My parent name will be propane, and I have a substituent on carbon 2. So substituent on carbon 2, this is 2 bromopropane. 2 bromopropane. So this is the name of this compound. So that is how you name all the structure. I'm going to draw some question at the end of this video where you can name different compound of your choice. So if you have not subscribed to this channel, do it to subscribe to this channel at Tutor Sam Academic. Like and share.